I'm hoping we can get Strat on here, man. Michael Strat, he's already on the airplane back at the airport. I'm gonna shut down the stream, guys. Everyone, thank you for watching. I gotta start wrapping up and go to the airport myself here. But it was great. Great seeing you all, and you know, when I come to the conference in a city near you, we can all meet up, and someday it will happen for sure. So.
Exactly. Much love and respect. Safe travels, everybody, and we'll see you again next month.
Heck yeah. Thank you. Thank you, everyone who joined us live. You guys rock. So have a good night. And I'll be posting the StreamYard link for the after party, or actually we'll just hang out on Zoom. I don't know. But I'm ending the broadcast so we can hang out here. Everyone, it's all off the record now. All right, break out the beers.
So I'm curious, did you guys see this recent Webb telescope thing where they're looking at stars, galaxies close to the Big Bang?
Oh yeah, they're able to see even further and further back now.
Well, they basically don't think there was a Big Bang then.
Yeah.
So basically the theory is of the Big Bang is that if you look back,
all the redshift, they get redshifted.
Well, redshifting isn't because of everything's expanding. It's actually because stuff is getting farther apart from each other.
Right.
But so basically what we were assuming in the Big Bang is that sometime in the past, everything was packed together in like our galaxy, that our galaxy would have been smaller.
Yeah.
So when they looked back to 100 million years after the so-called Big Bang, they found that there were spiral galaxies like ours, and they were the same size they are now. Okay. And that what was expanding was the universe. The universe is getting bigger, but the stuff of it in it is the same size. That means it's growing, like it's alive.
Yeah.
Okay. And it means that it's forever. There's no beginning and end. And that's what the Aztecs and the Mayans believed. And some of the I think the Indian, like
I agree on the conscious universe for sure.
I gotta ask that.
Much love. Sorry, I gotta take off. We'll catch you on the next one, or probably sooner. To most of you, safe travels. See you soon.
Everything's infinite.
Yes, thank you, Bernard.
And so if everything's infinite, then everything reoccurs infinite an infinite number of times.
Well, yeah, this is a cyclic universe.
It's a cyclical universe. The point of departure is the point
so
of
the
entry.
Hubble constants
So the Aztecs,
Yeah, it's broken.
you look at the Aztecs sunstone calendar.
Well,
There's 13 glyphs. There's 13 glyphs on it. And that's because they have 13 constellations.
okay.
And the one or the zero, the 13th constellation or the 0 point
outside of what they thought it was.
is
Same thing with the W boson mass.
is the Quetzalcoatl, the winged serpent.
Okay.
Okay, now the
standard model is
Greeks
cosmology
had 13 constellations,
Okay.
but they got rid of the 13th constellation because the Christians didn't like snakes.
Interesting.
And the 13th constellation is called Ophiuchus. Okay, Ophiuchus, it's called the Serpent Bearer.
Okay.
And it's located in the center of the Milky Way galaxy. So it's actually a black hole. And that's why, so they basically believe everything goes in a cycle. That's why it's the point. And like a black hole, and like a cell, there's a nucleus, or it's a black hole, and there's an outer event horizon, or this membrane, the edge. Okay, so it's like, that's what our universe is like. That's what everything, that's what life is.
This is what Keith Cooper has to say on space.com. The Big Bang Theory is still on solid ground despite pseudoscientific attempts to twist the James Webb Telescope's findings. Said James Webb Telescope never disproved the Big Bang. Here's how that falsehood spread. Oh, great.
It's up for us to decide. There's always going to be skeptics and those adherents to want to preserve the status quo. In their interest in there's those who want to preserve the so-called standard model.
Eric Lerner.
Yeah, these concerns like,
There's a lot of money riding
Yeah.
on it being right, but I always like being wrong. It makes me happy when I'm wrong. It really does, because it means that, I was starting to believe my own karmic delusions. And after all, I'm just an insignificant human, right? Alleged in my own mind.
everything's connected. So like,
It's all connected, and we're all the same. We all have the same feelings and needs. So,
Everything about this.
so yeah, if you could find that, if I could log in, I could show it to you. It's not that long. You got to go run off somewhere though.
it's kind of the airport soon.
I have to go to the airport in
When
about an hour.
about an hour. So can I log on the internet here? Is it on the
Yeah,
internet?
What, you want to look something up? Or,
No, I'm just gonna open the link to the video that I was talking about the James Webb, and now looks like it was a legit video.
Yeah, let's check it out.
or share it.
I didn't know Nick West had watched
Mick Westy.
it. I love skeptics and trolls and Twitter bots. I like all these things. They're all cool.
How much of Twitter do you think is bots?
Oh, about 2/3.
Yeah, it's
I
Elon,
think
there's some sort of, comment about that.
Do you think so too?
I think so.
Yeah, I think.
I've seen so much of the AI now that I've been here and like getting the tour. I'm like, oh God, everything I suspected is not only true, but it's worse.
Yeah,
Fakes.
exactly.
Everywhere.
Okay, inbox. That's not that's your email.
Did you ever find it experience? No. It was all bots. It was ridiculous. But it was not like clever bots or anything. It's just advertising, marketing, nonsense. That's how some people move money. Yeah. I don't understand the mechanics of how that works. But ad tech is, I don't know what it is, but it's not ads, man. No one clicks on ads. Everyone uses ad blockers, right? Yeah. It's a guy that was wildly.
Okay, now how do I let's see.
Yeah, yeah, he ran a
Sign
company
out, add, sign
to SEO, to ad related ad tech stuff.
There
It
you
made
go.
absolute no sense to me as business model. In terms of, see if I can. Maybe people can click on ads. I don't click on ads. Sure.
What is this? Verify it's you. Okay.
You have to click it on your phone. It wants you to do another off.
Click on what? What do I do now?
Oh, if your phone, you have your phone on?
Yeah.
It'll show up on your phone and you have to hit that to verify because it's new.
Oh, you gonna log in on my thing?
Oh, I was just logging into Gmail so I could open this link. Sign in, yes. Yes, it's me. Wow,
Okay.
32. That's pretty cool. I never did that
Never did
before.
that
So
before.
like clicks.
Yeah.
You basically.
Now it wants to verify
But
again.
it's not like SEO.
Yes, it's me.
Yeah, it's fine.
That's probably just for everyone who's
Continue to
like.
sign in. You
my
make sure you sign out so
Want to see
you're done.
more
Oh,
activity.
okay, yeah, we'll do. Or else it'll be
so
stuck.
that way I could hack your
Yeah, it seems
emails.
like
and
okay.
Yeah, well, That's fine, I don't care.
Give me a cut. Yeah, next round of footage.
Little drama never
Just
hurt.
seconds it off.
Okay, here we go. I'll just like log out as soon as I get this thing. Okay. Stephen, James Webb.
That's what they're saying it is. It's like the big
Here we go.
denier.
Yeah.
There's all these people.
Okay.
It's not in every mainstream.
3. There we go.
Got denied like, I feel like 6 journals before he finally got his first stuff published. Or a couple of them. They were like, no.
Stephen
Your
Hawking.
patent office guy.
The James Webb Space Telescope has revolutionized the way we look at the universe in less than a year. Since its launch on December 25th, 2021, multiple images captured by the largest telescope with potentially the highest infrared resolution and sensitivity have been going viral around the globe. The James Webb is no doubt the most advanced telescope in human history. The telescope's integrated science instrument module, or ISIM framework, provides it with electrical power, computing framework, cooling capability, and structural stability. The ISIM also holds the 4 science instruments and the guide camera of the telescope. The infrared imager NIRCam serves as the observatory's wavefront sensor, while the NIRSpec performs spectroscopy over the same wavelength range as that of the NIRCam. The mid-infrared instrument measures the mid to long infrared wavelengths. The fine guide and center, a near-infrared imager, the slickless spectrograph, is used to stabilize the line of sight during the science observations. So far, the images and data received from the JWST are well worth the $10 billion spent on building this miraculous invention. The first ever in ages from the telescope was revealed to the world on July 12, 2022. And experts believe these pictures from the largest and most powerful telescope in the world demonstrate Webb at its absolute best, fully prepared to further unravel the infrared universe. These included images of cosmic cliffs in the Carina Nebula, exoplanet WASP-06b, Southern Ring Nebula, Stephan's Quintet, the brilliant deep field view of the universe. But these were just the first batch. Since then, the James Webb Space Telescope has provided scientists with even more dazzling and awe-inspiring images of the cosmos. Some of these images have left astronomers and cosmologists quite confused. A flood of astronomical papers has been published since the revelation of these images and data from the JWST. A few of these papers have incited panic among the cosmologists. But what exactly is the reason behind this wave of panic? Well, it's the assumption that the findings of the James Webb Space Telescope are blatantly and repeatedly contradicting the Big Bang Theory. In order to understand what's going on, we first need to understand what the Big Bang exactly is. The Big Bang is the prevailing cosmological model that explains the evolution of the observable universe. It was developed from observations of the structure of the universe and from theoretical considerations. It explains how the universe expanded from an initial state of high density and temperature. This model offers a comprehensive explanation for a broad range of observed phenomenon, including the abundance of light elements, large-scale structure, and cosmic microwave background. It is compatible with the Hubble-Lemaitre law, which proposes that the farther away a galaxy is, the faster it is moving away from Earth. The theory describes an increasingly concentrated cosmos preceded by a singularity in which space and time lose meaning. According to detailed measurements of the expansion rate of our universe, the Big Bang singularity is estimated at about 13.787 plus or minus 0.02 billion years ago, which is also the approximate age of the universe. The concept of the Big Bang is quite simple and easy to understand. However, the Big Bang is considered quite a misleading name for the expanding universe. The name conveys the idea of a firecracker exploding at a particular time and a place with a center. But the infinite universe is actually expanding into itself, and the universe doesn't have a center. The Big Bang actually happened everywhere at once. It was a process occurring in time, not a certain point in time. This is justified by the galaxies rushing away from each other and not from a particular central point. And we see the heat left behind from these earliest times, which uniformly fills the universe. And as much as we'd like to see it, the Big Bang is not something we can see, but that doesn't mean there are no observable signs of it. According to scientists, we can visualize the heat that was there about 380,000 years ago. This heat covers the entire sky and fills the universe around us. NASA and the ESA were able to map it out using satellites called the Cosmic Background Explorer, the Wilkins Microwave Anisotropy Probe, and Planck. At this point, the universe was extremely smooth, with only tiny ripples in temperature. The JWST was designed to see a period of the universe's history that we have not yet seen before, instead of seeing the beginnings of the universe. The Cosmic Background Explorer, the Wilkins Microwave Anisotropy Probe, and Planck have all seen further back than the James Webb. The main purpose of the James Webb Space Telescope is to visualize the first objects that formed as the universe began cooling down after the Big Bang. According to Dr. John Mather, a senior project scientist for the James Webb Space Telescope, that time period is perhaps hundreds of millions of years later than the one the other satellites were built to see. Dr. Mather thinks that the tiny ripples of temperature that these satellites observed were the seeds that eventually grew into new galaxies. What humanity doesn't know is how and exactly when the first stars and galaxies formed in the universe. This is the question the James Webb Space Telescope was built to answer. So to summarize, the Big Bang Theory is the leading explanation for how the universe began. And in its most simple form, it says that the universe as we know it started with an infinitely hot and dense single point that inflated.
You can't get something.
A house or a laptop?
Yeah,
Which
that's
one do you
good
think is
timing.
worth more? Well, definitely not the house, because it not only costs.
Nothing's free in America.
Stretched initially at unimaginable speeds and then at a relatively measurable rate over the next 13.8 billion years to the still expanding cosmos we see today. So
I'm
far,
making
the
some
Big Bang
batteries right
is
now.
our best guess about the origins of our universe.
They're
But
made
now
out
it
of
seems that these
carbon,
new images from the
rods
JWST
and,
are
wrapped
making
in
some scientists doubt the credibility of this
liquid, and
theory.
you just put water
The
on
Big
it,
Bang
and
Theory has been
that
defended
has
for
all its
multiple
depth,
decades
it
as an
makes
unquestionable truth by most cosmological theorists.
application.
But the new data from the JWST is making
Plan.
ones like Alison Kirkpatrick
Mad
panic.
science.
She's an
Mad
astronomer at the
scientist.
University of Kansas in Lawrence. According to her, the
Not
latest
crazy,
revelations
just
have made her question whether everything she's done in the field is wrong. Incredibly small,
That's
smooth,
right.
old, and surprisingly numerous galaxies are completely incompatible with the Big Bang hypothesis. The opinion of a few
They found
scientists.
galaxies
Big
that are
Bang
too old.
proposes that the universe is expanding and a strange optical illusion must exist in outer space. Galaxies and other objects in the expanding space do not continue to look smaller with increasing distance. Beyond a certain point, they start getting bigger, as their light is supposed to have left them when they were close to us. But the images of the JWST show them getting smaller and smaller. Even the galaxies with much greater luminosity and mass than our own Milky Way appear 2 to 3 times smaller in these images. In other words, the galaxies the JWST is showing us are the same size as the galaxies near us, indicating that the universe isn't expanding and the redshift isn't proportional to distance. The newer galaxies in the images have a redshift that is 2 to 3 times greater. This strongly contradicts the theory of an expanding universe. The
Later,
opinion
we talk
of Eric
about
Lerner
that
and Ricardo
the
Scarpa
universe is
but
expanding.
aligns with their
It's
prediction
growing.
that we are
It's just
part
stuff
of a
in it.
non-expanding universe. They had previously published results
It's
based on
alive.
Hubble Space Telescope
It's
images
alive.
that show the galaxies have a redshift all the way up to 5 that match the expectations of non-expanding ordinary space. They were confident that the James Webb would only confirm their hypothesis. Big Bang theorists had expected to see badly mangled galaxies scrambled by multiple collisions and mergers. However, the JWST images actually showed overwhelmingly smooth disks and neat spiral forms, just like we see in today's galaxies. The data in the Panic article shows that there were around 10 times more smooth spiral galaxies than predicted, and this challenges our ideas about mergers being a very common process. According to Lerner and Scarpa, this data utterly destroys the merger theory. The Big Bang theory implies that the most distant galaxies in the James Webb images are seen as they were about 400 to 500 million years after the origin of our universe. But some of the galaxies have shown stellar populations that are at least 8 billion years old. Now, according to the Big Bang theory, Nothing could have originated prior to it, so the authors of the panic article believe that the existence of these galaxies is proof that the Big Bang didn't occur. And just as there must be no galaxies older than the Big Bang, so theorists expected that as the JWST looked out further in space and time, the galaxies would become fewer and eventually there would be none left, signifying a dark age in the cosmos. But a paper yet to be published demonstrates that galaxies as huge as the Milky Way are common even a few 100 million years after the hypothesized Big Bang. From the Big Bang standpoint, the distant galaxies are supposed to be intrinsically smaller. One galaxy noted in the papers is GHZ2. It is far more luminous than the Milky Way and yet is...
Do not buy solar panels. If you live in one of these 11 states of America, it's the worst decision you could make for your home.
It's calculated to be just 300 light years in radius. This is 150 times smaller than the Milky Way. And the JWST images aren't the only reason the Big Bang theory may be considered wrong according to Lerner. He believes that right now the Big Bang makes 16 wrong predictions and only one that is correct. Its prediction of helium is off by a factor of 2. The prediction of the abundance of lithium is off by a factor of 20. And besides the absence of larger and more distant optical illusions, there is also the existence of large-scale structures too big to have formed in the time since the Big Bang. Most cosmologists and astronomers have stated that there's an explanation for every doubt Lerner and Scarpa's article has raised. The Big Bang is definitely not dead, and the recent observations of the JWST haven't disproven the theory. These observations revealed some unexpected and strange things about the universe, but that's all. The Big Bang is centered around 2 facts. First, that more distant galaxies have a higher redshift than closer ones. And second, that the universe is filled with a cosmic background of microwave radiation. These constitute 2 of the 3 pillars of data supporting the Big Bang theory. The third one being the relative abundance of elements in the early universe. But these are just the foundation of the model. In past years, scientists have expanded on these to create the standard model of cosmology, also called the LCD model. Everything from acceleration of cosmic expansion to the clustering of galaxies support this model. The Tolman test predicts that if the universe was non-expanding and static, the surface brightness of all the galaxies would be the same, regardless of the distance, which isn't the case, as evident by the JWST images. The distant galaxies have a dimmer surface brightness than the closer ones in these images. It is a common misconception that redshift proves that galaxies are speeding away. They aren't in reality. Distant galaxies aren't speeding through space. In fact, space itself is expanding and thereby putting greater distance between us. This subtle difference emphasizes that the galactic redshift is a result of cosmic expansion and not relative motion. Experts aren't denying that what the James Webb Space Telescope found doesn't entirely align with their predictions, but astronomers were hoping to find this sort of puzzling data. They believe that is the reason why so much was invested in building the James Webb Space Telescope in the first place, and they understand that the data collected by this magnificent telescope doesn't tell us that the Big Bang model is wrong, as some of their assumptions about it could be. The largely publicized attempt to discredit the Big Bang isn't the only thing triggered by the James Webb Space Telescope images. There's more, and this is actually good news. Just a few weeks after the first images of the JWST were made public, the telescope found a galaxy that existed about 13.5 billion years ago. The glass Z13 galaxy dates back to around 300 million years after the Big Bang, which is 100 million years earlier than anything previously identified. Rohan Naidu of the Harvard Center for Astrophysics has said that we're potentially looking at the most distant starlight that anyone has ever seen. It was spotted in the so-called early release data from the James Webb's NIRCam. After translation from infrared into visible spectrum, it looks like a blob of red with white in its center as a part of the wider image of the distant cosmos known as the deep field. The scientists analyzing the data from the James Webb have found out that this galaxy is the mass of 1 billion suns. It is quite a surprising feature that they do not understand, but they're looking forward to finding out more once the Webb's managers give them telescope time to carry out spectroscopy.
Just as a
Do
way.
you think there are even older
So it's
galaxies
like a
out there?
wave.
Darlana and Scarpa onto
You know,
something
you
with
draw
their
a wave
theory
like
of the non-expanding
sine wave,
universe.
pull
Tell
the
us in the
two
comments
parts
below.
apart. It's just because the particle of the spin is what's entangled, right?
Yeah.
So I learned
To
about,
really get math
I
and
learned about
science.
quantum
You
entangling.
gotta do it. That's why learning on Brilliant is so great.
It's interactive.
I learned about it in the 80s when I was working on infrared detectors. They had these the early diode or junction was called a Schottky diode.
Oh,
And what it is just a piece of metal on a semiconductor. And with this, and basically there's different charge exchange mechanisms in the junction.
I was researching this yesterday for hot ground impulse experiment, kind of layers to put in between.
So there's what's called a diffusion limited diode, and what that's like a silicon diode. And the diode has a P region, which is positively charged, or holes, or excess of protons, essentially. And then on the other side is the N side, which is has a lot of electrons. And it's called the N side and the P side. So in a diffusion limited diode, say we have a thin P layer on top of a thick N layer. In a diffusion limited diode, the charge interaction region covers the whole bulk width of the thing, the total thickness. And then as you cool this junction down, at a certain temperature, it goes to what's called generation recombination region. And then that basically it forms like a little, best to describe it, kind of looks like a drop or a part. It doesn't cover the whole region at end. It makes it like a little region, which is called the depletion region in the diode, and it's where the protons and the electrons exchange information, that's why it's called generation recombination. And then as you get really cold, like below 50 degrees Kelvin, at that region, you get what's called a tunneling mechanism. And that simulates a Schottky diode, because the Schottky diode is basically, it's like there's just a piece of metal there in the semiconductor. And what happens there is you get what's called tunneling current. And what tunneling current is on one side of the junction, it goes, instead of looking, a diode is kind of like this. And the tunneling diode, it pushes over to the positive, the forward bias, and it goes up and then it goes down and it makes a little loop. And so what it has is there's a region where the spin of the electrons on one side are the exact opposite of the other side. And that's the earliest example we had of entanglement.
Diffusion limited.
In a tunneling diode, it's called.
Okay.
It's called a tunneling junction, or a quantum tunneling is the term that is used. And that's where you create these two spin states of the electrons where they're exactly of the opposite. And it looks just like a standing wave. You look at it on the curve tracer, it's called. It looks just like a standing wave. It's pretty cool. And essentially, that's what you're doing there is you're creating a barrier between one medium and another medium. It also works if you go the other way. So if you go from a material into empty space, there's a junction there. And you can create this same kind of tunneling mechanism. And that's basically when we're talking about, oh, we opened up a wormhole. Well, it's not. It's more of a tunnel than a wormhole. It's a tunneling mechanism between the two sides. Okay, and they have this, and this also occurs in the Earth interacting with the surface of the sun.
Okay.
They have these things called X points. I don't know if you've ever heard of it. And so there's like this shock wave that comes from the sun. And then there's this other region of the Earth's magnetosphere like pushed back, and it creates like a region. It looks kind of like, and then again, you get this tunneling mechanism going on between the Earth and the sun. And this actually causes phenomena on in the Earth's atmosphere that have been classified as UFOs, because they're like little plasma torids that form, and they look like ball lightning basically. And it's basically what's going on is there's a solar flare or some kind of solar phenomena that's interacting with the surface of the Earth.
I heard of like high altitude elves and like
Elves is an example of positive lightning. An elf looks like a little circle. Okay, and then there's this other thing called a sprite. Yeah, I heard that. And it looks like kind of like a jellyfish when you look at it. But when it's positive lightning, it's lightning going up instead of down.
yeah.
Because the Earth is ground. It's like negative. It's like the inside of the diet.
I mean, why would the Chinese government not want to pump
So
information?
all that phenomena,
I mean, that's to me, for her to go back to China seems like
it's just magnetics, it's just
Well,
ionization.
it's
Information already.
well, gravity and magnetism are related,
Yeah,
but electromagnetism is so electromagnetism is independent from gravitation.
I feel like they kind of want.
People think that that gravity is a form of electromagnetism. It's not. It's related to magnetism.
Right.
Oh, you gotta take off, dude? Right now?
I just gotta start packing, so we're ready to leave.
Did you stay here? Where'd you stay?
Just at the Hilton down the street.
Yeah. How was that?
Oh, Michael, this is for you, by the
Oh,
way.
cool, thanks.
I just got a picture of me, you, and Jeremy then.
Yeah. That's awesome.
yeah, it could just be a spin effect, right?
Yeah, exactly. So, yeah, spin.
Means if you make like a spintronic circuit, you can control gravity.
Right. That's what gravity is, a type of phonon. It has to do with more with sound than it does with electricity.
Faraday shield and.
Oh, that's cool. Yeah, I've got one of those blue lab coats with the little ESD lab coats. You know what I mean? Because those are good, and I encourage you guys to use your ground straps.
Doesn't have a ground strap.
You don't have a ground strap.
No, this is floating. Well, we could attach a ground strap if we're gonna be
But
stationary.
you saw how messed up Tesla was in the end there? He didn't believe in a ground strap either.
It's a chair.
No, he's sitting in a big metal cage, but that doesn't stop the RF from cooking you. There's stuff of the right wavelength and to get through that stuff, you know. It only shields you for a certain bandwidth of EM. And he liked to play with that high voltage shit, man. I think that's kind of scary myself.
You know that DARPA worked on it's kind of arc extinguisher. So high voltage, like a flame is kind of has a.
This is our latest Alzaphan based experiment. It's a waveguide chamber. One wavelength long.
Aluminum?
One wavelength diameter, yes. Aluminum.
Oh, one wavelength long, one wavelength diameter, okay.
Inner dimensions, and the antenna goes in from there to quarter wavelength.
Huh.
And we're gonna put a little bit of ferrofluid on the outside, so you can inside the magnet, see if the entire thing would be
You're gonna put what in it?
ferrofluid, just a little bit of iron.
Oh,
Ferrofluid, just like.
so this is,
That's aluminum.
so what I would suggest you do is you put it on top of a ultrasonic source. And sit- Well, just sit it like down on like the ultrasonic source and it'll make little modes. If, you know, have you ever looked at what is it? There's like sound experiments where they put these little carbon or metal.
Yeah, I've seen that.
And then it makes these different
Yeah.
different sound modes.
Yeah.
That's what would happen if you did that with
So
that.
why would I want to do that?
So you can tune it to the frequency of the signal. You're gonna, it's a waveguide.
Yeah,
So
it's
you
a
want,
working
if you get 2 waves or 3 waves
I was just gonna
to
look at-
harmonize, you can create power.
I was just looking for, I was just looking to see what frequency it resonates at,
Oh,
based on the setup that I put in. And then, based on that frequency, adjust the magnetic fields that were in our mark possession, dynamic communication, and this entire sample. That would
Okay.
be- So the.
And then it's gonna
coaxial
create,
coloring-
but so you're gonna have a changing magnetic field, right?
Yeah, 9.5 gigahertz roughly.
So, and then it's gonna, as it changes the magnetic field, that's gonna create, there's gonna, as it goes from one to the side to the other, it's gonna have a magnetic hysteresis, right? And then there's a frequency that you can tune that, the resonance of your ultrasonic resonator to the resonance of you get where I'm going with this? Once you know what the natural frequency is of this, then you can match it to, like I said, a ultrasonic, create one of these harmonics where you get like.
Why would I want both a physical resonance and an electric resonance going on simultaneously?
Because you can.
They're very different frequencies.
Well, one's not, what did you have? What was the frequency you were talking about?
9.5 gigahertz.
Oh, gigahertz. Yeah, it's way too. Well, there's got to be some.
I mean, that is what's happening in the gravity flyer. You got ultrasonics. And you also have Tesla coils, very
Right.
different frequencies.
And how high frequency is the Tesla coil?
Tesla coil.
Megahertz?
No, they're usually around 100 kilohertz.
Oh, they're lower frequency. That's why.
Yeah, Tesla coil is lower frequency than the ultrasonic is usually.
Well, why do you think it wouldn't work for higher frequency difference? Because you can fit more waves in there. You know what I mean?
I don't know. We're just looking at the. See if we can do anything with alpha.
Yeah.
Try it like
So
that.
what did his Altamont, what was his claim? That he was reducing the weight or something?
Yeah, it was reducing the weight by 80%.
Oh, wow.
Dynamic orientation. It
Interesting.
turns out that our waveguide that Tanya Slawetsky recommended that we build is completely off on dimensions. Dimensions are extremely important. I just
Yeah.
discovered that through this new book that I got.
So do you,
Practitioner guide.
did either of you get that metamaterial book?
Oh, yeah.
It's right there.
Okay, cool. Because that has some really good stuff about split ring resonators.
Yeah, I wasn't sure. We were able to make split ring resonators, but I wasn't sure how to determine its frequency and how to.
Well, the way you
Design.
do it is, do you have a network analyzer?
Yeah.
So you measure it. You do
Do you just hit it with the noise?
S1, S2. It has to be, the geometry of the thing it's like, they talk about it in the book. Basically, they do like examples where they show you, they give you all the dimensions and then they show you the equations.
Right, I wasn't sure about the equations, how that would work out for a specific frequency to.
So like bounce back and forth between the two. I would think the frequency would be related to the distance of the.
I think the centerpiece is, they're both floating, right?
Well, it depends on the configuration and what you're trying to achieve.
The idea is that it's supposed to be floating, right?
Well, there's a little,
Negative
here's a
index. Here's a
unit cell. And you see, they give you all the dimensions here and they talk about the frequencies and then they show you data. this nifty little table here. Here you go. Here's another one. So, I mean, these are simple ones. They give you, here's your AB, you know, they got all the dimensions here. But they're measuring it with a, see, like S21 dB. They're measuring it with a network analyzer. So I used to do these RF measurements when I worked at the test lab.
Are they doing just a noise generator?
Well, no, what it is it sweeps the frequency out, the output sweeps out the frequency. And then you detect on the other side, you detect what gets through and what doesn't as the frequency moves across, you know. So it's basically, this is like a spectrum generator. You're looking at the right, and you're measuring your source, your output, and that lets you derive. Yeah, you want to see what's returned too. You measure the return loss too.
Guys, I gotta shut this down. Zoom cloud meeting.
Yeah, exactly. Well, this is transmission. The transmission level through 5 centimeter thick slag.
Good night.
Good night. Have a good night, guys. I gotta go get my flight.
It was great.
It was great, man.
Thanks.